thank you very much.
So welcome everybody to this session, this breakout session of the ECCM 2021 conference that we have today. This is indeed one of the breakout session, the one on national power infrastructure. Reason why we chose this topic is because in the years to come we will see that several of the national grid infrastructures will have to start interacting with each other. Part of this challenge is related to the gas infrastructure, and therefore I'm very happy that we are able to have Jörg Gigler talk about how this will be done and what the vision is on that part. And obviously there's another grid infrastructure that's on power, and on that part Maarten Abbenhuis is one of our speakers, and he will talk about the way TenneT envisions how this will be developed in the years to come. Jörg is director of the Dutch New Gas Innovation Team, TKI New Gas, especially working on hydrogen, sustainable gases and power to gas infrastructures. And he had many positions already in gas consultancy, gas industry, and governance. Maarten, he is COO of TenneT and managing director of the TenneT TSO in the Netherlands. Already since 2009, Maarten was with TenneT, holding several management positions there. And beside the position at TenneT, Maarten is also a member of the board of the Dutch Energy Data Exchange. That's indeed the one I was looking for. Very good. What I would want to do is indeed have Jörg and Maarten present their visions first, and then later on have a discussion via the link that we have. On the side, on the left-hand side of your screen, there's a possibility to raise questions, type them in, and then we'll take the questions from there at the end of Maarten's presentation. I think the moment is there, Jörg, for me to hand over to you, and hope you can take over.
Thank you very much, Ronald. I will now start sharing my screen, and let me see if this works. Yes, it does. And then I have to go to this screen. Yes, and my question is, can you see my screen starting with the opening slide, electrochemical conversion and materials?
Yes, we can. I think.
Okay, thank you. Perfect. Well, ladies and gentlemen, it's a great pleasure to talk to you, and I'm doing this from the location of ISPT, the Institute of Sustainable Process Technology in Amersfoort, where I am located, and which has a very important position to fulfill in the field of hydrogen with a very nice track record. So what I would like to talk about is the National Hydrogen Program, which I am chairing amongst other things. And what's important to know about the National Hydrogen Program, in Dutch Nationaal Waterstofprogramma, is that the government and the Dutch Climate Agreement, they asked for the construction of a national program that would describe what is necessary to develop hydrogen successfully. And they asked us to compile in a group of stakeholders, in total 20 different branch organizations in the Netherlands, to compile this working plan for the National Hydrogen Program that has a operating period of at least 2022 until 2025, but preferably we should also focus on 2030. And this work has been done in the last 6 months, and I would like to present the results here to you. Let's say the preliminary results. And what's important is we said, okay, if we have to draft a working plan for the National Hydrogen Program and for the development of hydrogen, what's the best way to do that? And we said, okay, the first thing we have to do is we have to look at the value chain of hydrogen, starting with production, import and export, through infrastructure and storage to utilization and use of hydrogen in several markets. And you can see a thorough explanation in the bottom of this graph about the different building blocks. So we said this is our starting point, the hydrogen value chain, which needs to be developed to actually develop hydrogen in itself. Beside this, because this is quite a technical approach, we said we also have some cross-cutting themes that we need to include, because else we miss out on many different so-called boundary conditions or conditions that have to be fulfilled to make the development of hydrogen a success. And things, issues you could think about is, let's say, safety, the establishment of a manufacturing industry, the market and the trade of hydrogen, international collaboration, certification, all the regulation on national and European level, as well as investment. So what you can see here in this graph is on the top, you can see the hydrogen value chain, and here you can see cross-cutting themes, in total about 20 themes. And with this working group in the last 6 months, we worked out all these topics. Well, don't be afraid that I will treat all those topics with you. I will just now take the next step to look at our conceptual approach, because we said, okay, let's start now solving this. Let's start building this hydrogen future. And we see actually 3 building blocks. The first one is that we said we have to focus in the next couple of years of the large-scale development of hydrogen chains in industry clusters and harbors, which means more offshore wind and the integration, as well as solar, centralized production of hydrogen, possibly import of hydrogen on the one hand, so that's about the availability of hydrogen, and on the other hand, the use of hydrogen as a feedstock and fuel in industry, as well as for storage and production of electricity. So this is really the large scale. And why are we doing this? To build up, demonstrate and facilitate the rollout of hydrogen value chains in industry clusters and harbors. So that's the one development. The second one we said is you also have to do this on a decentralized level. So to develop hydrogen chains in the regions, for example, based on local hydrogen production, and you can, for example, solve in this way grid congestion to support the integration of renewables and use it, for example, in mobility, in the built environment, or in the small-scale industry that can be found in the region. So this is important to develop local infrastructure for hydrogen as well as storage, but also to involve the public in the development of hydrogen, because what you see on the left-hand side is all focused on large-scale behind the fence of factories or harbors. So the public doesn't see it, but we need to bring hydrogen to the public. And the third one, and I'm coming to the end of my presentation, is we need to create the right conditions to make this development possible, which means the policy instruments have to be there, markets need to be developed, safety, certification, well, you can see all those different issues here. Also promote international collaboration, which is very important also within the framework of a conference like we have with ECCM today. And let's not forget to support innovation and to develop the human capital that is necessary to do all this work. So this is, let's say, the conceptual approach. And well, what will we do with this national program? We are about to finish it. We will hand it over to the Minister of Economic Affairs and Climate in about 2 weeks. And we will start with this program officially at the 1st of January 2022. But actually we have already started. We started already about a year ago. So it's just ongoing business, but then focused on large-scale development as well as decentralized development. And that's the last slide I would like to share with you. And I'm looking forward to any questions you may have.
Jörg, thanks very much. What I would propose to do, and I already mentioned at the beginning, to have Maarten take the floor now and indeed tell the vision of TenneT where it comes to the expansion of the electrical grid environment, and then take it from there with the discussions on these themes. Maarten, can I give you the floor?
Yes. All right. So thank you. I will share my screen as well. Hopefully you can all see my screen now. Just give me a thumbs up. Hold on.
Not yet, Maarten.
This will work. A second. Here we go.
There you go.
This should work.
Perfect.
So,
Yes.
Ronald, thank you very much for your invitation and inviting me here to have a brief presentation. So, what I would like to achieve in the next 10 minutes is take you briefly through what TenneT is about as an organization, and then zoom in on the electricity part of the energy transition and especially connecting it to the hydrogen ambitions. Now let's see if I can go to the next slide. Here we go. We are in a huge transition, and this slide I will not take you through in detail, but it shows that actually the electricity landscape has been in transitions since decades, where we moved from very municipality originally based grids to provinces to nationals, with the end of, not even the end, but our acquisition of the German part of TenneT in 2010, where we became the first cross-border TSO. So in fact, the transition is a huge challenge, but the landscape has been in transition for several decades. Our legal tasks as a TSO is, of course, to execute all the transmission services, which means bringing all the electricity that is generated from A to B, where B is the load or the consumption of it. This used to be an easy one, so the generation followed the demand, but we now clearly see the impact of renewables in our systems, where we already in the Netherlands see days where 60% of the load is covered by renewables. Second responsibility we have is system services. This is often hidden for the general public, but this is our responsibility to keep load and generation at all times in balance. It is in Europe, we have agreed to run the system at 50 Hertz, and this can only happen if demand and production are always equal. Again, here, this is a more dynamic state and game than we had in the past. And here we also use many more suppliers than we did in the past. I will come back to that later. And the third one is market facilitation. We are obliged to have an efficient running and stable market so that all the capacity that we have in our grid can be used by the industry and consumers. These are some facts, and probably the slides will be shared afterwards, so I'm not going to spend too much time on it. The interesting one is, of course, our workforce, which is very important for the energy transition. I started working for TenneT as approximately employee number 800, where currently we have an organization of over 5,700 people, and we envisage a significant growth in the next years to come. And all this we have to do by keeping the lights on. So we are working, expanding and innovating in a system that is running. Therefore, in the left corner, you see the 99.9999 availability that we achieved in 2020. And this is the important slide when it comes down to how are we going to produce all these kind of electrons that are needed for conversion. We have an approach in the Netherlands, but also in Germany, as we are a cross-border TSO, that will deliver in 2030 approximately 17 gigawatts of wind power to be landed onshore. Where we started off in Germany with relatively small wind parks growing to 900 megawatts direct current. We have implemented in the Netherlands a programmable approach, a more standardized approach, with 700 megawatt farms distributed along the coastlines. And after the year 2027, we will scale up once again in both the Netherlands and Germany to start constructing the 2 gigawatt platforms, which is highly innovative. But this is needed in order to generate and to bring ashore all the needed electrons. And a step further on in time, so post 2030, we will work on hybrid systems where connection points are not only to transport offshore wind back to the mainland, but also have the connection points function as a trade cable between the countries such as the UK, Norway, Denmark, and Germany, to also have a social welfare gain in terms of low wind, where we can benefit from each other's systems dynamics. This slide can actually be summarized in 3 large conclusions that I would like to share with you before we kick off in the dialogue. So in all scenarios, we clearly see that significant investment, not only in generation, but also in grid, is required, including the backbone of H2. There is no scenario to reach the climate goals in 2030 and beyond without having both of these systems running. It is, however, very, very important that coordination and a joint roadmap is to be established by all parties that are connected to the energy transition. Second point I would like to mention is, of course, that location is very important. And this is part of the coordination. But to jointly define the landing points where we closely connect load and demand or conversion into molecules has a significant impact on the level to be invested, not only in the electricity grid, but also in the hydrogen backbone. And last topic is market specific. So we, with high volumes of renewable in our systems, with an increasing amount of demand somewhere in the system, and we need to still run this stable. Therefore, the flexibility and the need for flexibility, not only at the side of the TSOs, but also at the side of the industry, will become very important. So demand side management can even be a big revenue booster for the industry. We have recently published together with DNV a report on the potential in the current system in the Netherlands, which was approximately 4 gigawatts of demand side capability. And this will increase in the future, and it will make the system more stable. And that is a win-win for all. Thank you for your attention. I tried to keep this as brief as possible, just like Jörg, and I'm open for any questions or dialogue.
Maarten, thank you very much. I was struggling a bit with getting the microphone on, especially since we're sitting in the same room to avoid noises going around. Let's see. There's questions here. A couple already I got offline. First one I think is for Maarten, and it has to do with grid expansion. We see that the industry demand is expected to increase significantly in the next decades. What is the kind of thing that you expect from industry and the network operators in the industrial domain? Do we need a separate optimized industrial grid? Or do you see the possibility to expand the existing grid and indeed keep the grid more or less a unity in the enormous expansion expected?
Thank you. We don't need a separate grid. That is the simple answer, but there's lots of logic behind it. So the European interconnected grid is one of the most stable in the world. And a coordinated approach to strengthening this grid is of course needed. So with the steep increase of industrial load, we can clearly see that at some points in the grid congestion might arise or capacity constraints will appear. The question is, if we position the newly generated electricity close to the newly defined load center, which sounds relatively easy but takes a really coordination effort from all involved, I believe that the Northwestern European grid is very capable of accommodating all these flows, because we should not forget that the flow that goes that will be generated offshore and will be used in the load centers close to the landing points does not necessarily consume the capacity of the grid elsewhere. And this is the strong drive that we as TSOs have to make sure that we distribute the load and the distribution over the coastline. So I don't think we need a separate grid. I do believe that we should benefit from the characteristics that the European grid has, which is extremely stable.
And does it also mean that, because you mentioned the connections to the other countries, do you see that as a buffering option, and a very large one?
Yeah, that strongly depends on which country you are referring to. So in total, TenneT operates, I believe, 16 or 15 interconnectors. If we zoom in on the Netherlands slightly, we have 5 interconnections AC to Germany and Belgium, and we have DC, so direct current connectors to the UK, Norway, and Denmark. We can clearly see, if you want to benefit from each other's systems, that studies show that the DC interconnectors are most helpful when, for instance, in periods of shortage, compared to the AC connectors between Belgium and Germany, as the German and the Belgian systems are more or less connected and will have the same weather systems as the Netherlands. So if we have a shortage in the Netherlands, is it most likely that we also have a shortage in Belgium and Germany, and therefore the impact of safety is bigger from the DC connectors that go to different synchronous zones. But the strength of the total system is, of course, that we are not only connected to Belgium and Germany, but that Germany in itself is again connected to their neighbors, and Belgium again to France and Switzerland. France and other.
Yeah, I understand. So close by is indeed connected weather-wise, and countries further away, perhaps it's also more difficult to get the energy in because of the losses related. Perhaps that's another aspect that will play out.
Well, the losses is not relevant. Of course, losses are a phenomenon that cannot be ignored, of course, in terms of volume, but the capacity is here what is the constraining factor. Luckily, the production park within Western Europe, Northwestern Europe, is designed in such a way that we have plenty of feed-in points in the current grid. So I think transmission capacity is more relevant than grid losses.
Great, thanks so much. At this point, if anyone wants to tune in, please join us indeed with your questions by typing them in. There's another one, but that's hydrogen related. And that's especially a question relating to the need for energy and the option that hydrogen would have as a way to bring energy in from further away. So hydrogen transport is perceived as an option to bring energy to the Netherlands as a complement to the national renewable energy production. Then the question is, and I think that's to Jörg, at what scale do we need this kind of foreign hydrogen-based energy supply? How does it compete with for example, foreign electric supply? But perhaps first focusing on, do we need foreign hydrogen? And is there a possibility to bring it into our system?
Yes, thank you very much for this question. Well, I think the answer is certainly yes, because as the Netherlands, we are a very energy-intensive country, based on the fact that we had our own natural gas resources, and we still have a few. So we will never be self-sufficient. We will always be an importing and exporting country of energy and feedstock. So I think certainly we need energy from abroad when we say goodbye to fossil fuels. And the good thing about hydrogen is that we have the possibility to harvest electricity in places in the world where there's more wind and where there are better solar conditions and where the price of hydrogen can be lower. So yes, certainly I expect this, but looking at the exact question, well, in what share? My first answer is I don't have a clue. The second answer is that it depends on how much offshore wind and solar we will develop. Like I'm very happy to read that recently, or that we will soon decide that we will go from 11 gigawatts offshore wind to additional 10 gigawatts, so 21 gigawatt offshore wind in 2030. Of course, I would very much like to know from Maarten how he's going to deal with that. But that's a very good message. But I also think that for direct electrification, we need all that, at least the large share of that electricity. But certainly after 2030, we will have a lot of electricity available for the production of hydrogen. But if the infrastructure, the electricity infrastructure will become the limiting factor, or if we need storage, we may even produce our own green hydrogen much earlier than 2030. So I'm positive about it, but I'd also like to hear what Maarten has to say to that.
Maarten, the question was on how are we going to realize all the electrification from the electrolysis to come, grid-based?
Yeah, thank you for this question. What is important to mention here is what I briefly touched upon in my presentation is that the stability of the European synchronous area is because we are interconnected. So the resilience and the redundancy of the system is because we all pitch in, from Portugal to Poland and from Denmark to Greece. We all share and we all have contracts in place how much of this redundancy and these reserves that we require to have this redundancy is provided by the participants. That is a different question it's a different question when you discuss do you have the capacity to transport all the generated electricity. And as long as there is substitution in place, so we do not have conventional power plants running fully at the same time as we generate all the renewables, then the capacity impact should be manageable. And on this topic, TenneT publishes every year the monitoringsrapport leveringszekerheid, where we see what we can do and do we have enough electricity in the years to come. And the Dutch grid is relatively safe, but we see clearly that for some hours in the year we are dependent on our neighbors. This is not a bad thing. That is how we designed the system. But I agree with Jörg, if you generate 17 or more than 17 gigawatts of offshore wind and there is no electrification or load at logical places in the grid, then we cannot avoid that we have to curtail at some points in time the generation of renewables.
Great. I think this is bringing us to the end of this session. I invite everybody to start switching back to the main session, but not before I want to thank the speakers that we had today. And I hope you found the information useful. And I think there's more to come in the live streaming session that will be ongoing from 14:30 onwards. So thank you all for being in this breakout session, and I hope to see you soon back in the main session and perhaps later again. Goodbye.